I would like to introduce you to a new Cucurbit rootstock, Carolina Strongback. Purpose of this video is to give you an understanding of what makes Carolina Strongback a fantastic rootstock for cucurbit grafting, especially watermelons, as well as greenhouse cucumber production. It is not ideal or not a good rootstock for melon grafting. The outline that we're going to follow today is first we're going to talk to you about the attributes of Carolina Strongback, and then the light and temperature requirements to grow both the scion and the rootstock material, so that when grafting these, you produce a quality transplant that when taken to the field takes off immediately and produces you a quality vegetable transplant that further produces the production aspects that you expect from a quality rootstock. Then I want to talk to you about the timing and planting of both the rootstock and scion material, because they are different. Carolina Strongback is a different type of rootstock that we're going to describe to you, which requires a different line of thinking than the standard rootstock that you maybe have already been growing for a number of years. And then I want to talk to you about some of the growing characteristics that I have learned over the years in grafting, especially with the new Carolina Strongback rootstock. Carolina Strongback is basically a wild watermelon rootstock that was bred and developed by Dr. Pat Wechter at the USDA ARS in Charleston, South Carolina. All the evaluations of this rootstock were done by Dr. Richard Hassel at Clemson University, located in Charleston as well. It was developed and released by both Clemson University and the USDA ARS and licensed to the Syngenta Vegetable Seed Company. It has high levels and tolerance to Fusarium wilt, race 1 and 2. The advantage of this is it has multiple sites of resistance, so the chance of it becoming overcome that resistance over time is highly unlikely. It also has high levels and tolerance to nematodes, both types of nematodes that we see here in the United States. Also, it has high levels of tolerance to bacterial fruit blotch, as well as high levels of tolerance to downy mildew. Even though these are foliar diseases, we found that over the years that the graft union has the ability a lot of times to transport some of this tolerance across the graft union. First, I want to talk to you about the aspect of light and temperature. Over the past several years, we've done a lot of research in what we call the grow rooms, or artificial light and temperature, where we can control everything that goes on within the plants, growing these plants in an artificial environment. You know, many of you are using your greenhouses to grow both the scion and the rootstock material, and you don't have access to this type of an operation currently in the development of your grafting operation. But the purpose of this is to show you what the effects are of both light and temperature on the growth and development of both the scion material as well as the rootstock material. So keep that in mind as we go through this. Also, you'll notice in this slide that the light intensity is 200 micromoles. This is basically equivalent to a full sunny day. This just shows you the aspects of the chambers that we've been growing these plants in an artificial environment. You see the red and blue light, that's what plants recognize as they're growing. But I want you to keep that in mind as you look at the next few slides that show you the effect of both light and temperature has on the development of both the scion as well as the rootstock. Over the years, we've come up with what we think is the ideal length of the scion material. The ideal length that we shoot for basically is the 28 millimeters in length. Now we're only going to discuss length in this, but length is also correlated with the width of the hypocotyl that is very much correlated between the two. So to develop a thick hypocotyl as well as the length, these are the ideal circumstances, the ideal areas that we want to talk about. So we're shooting for a scion material that has 28 millimeters in length, basically an inch. This just shows you an example of that, which is the ideal scion length. I want to show you now the effects of what temperature and light duration has on the hypocotyl length. If you'll notice on this slide, you have the hypocotyl length, and on the x-axis, you have the various temperatures of those. The different colored bars are the amount of light duration over a 24-hour period. In other words, no light, which is the first bar, and 24 hours of light, which is the last bar in each of these. One thing I want to show you, in order to get that ideal circumstances, we find that we can grow the scion material close to 70 degrees Fahrenheit, it's possible, or 21.1 degrees C. And we have a light duration of 18 to 21. So if you have the time of year which you may be growing your scion material, that light intensity will change. So if you have an opportunity to supplement your growing area with artificial light, 18 to 21 hours of light is ideal at a 21 degrees temperature of Celsius. 21 degrees Celsius is ideal for scion material. This gives you an idea as to what happens when you increase that temperature to 75 or 23, 24 degrees Celsius. Just 5 degrees. Just 5 degrees Fahrenheit. What happens? What goes on? Or in other words, 3 degrees Celsius. How that affects that scion length. Now when we're looking at our rootstock material, this is Carolina Strongback again. We want a longer hypocotyl because we want to have that grafting union, that grafted plant tall enough that it does not come close to the soil that we have. This goes into practice when you go to put the plants out into the field. You do not want to bury that grafting union. If you do, that graft union will basically go back to the scion material that you've grafted and you've paid money on to develop. It'll go back to what it was before. And if you're in fusarium ground, it will be attacked by fusarium. So the ideal length that we've determined is 40 millimeters. This just gives you the Carolina Strongback in the 40 millimeter length. Notice that the cotyledon leaves are not all that big with this, but notice the thickness of them and notice the thickness of this hypocotyl. It's ideal, this length is ideal, making sure, because right here, this is the storage of all carbohydrates, both in the scion as well as the rootstock material. Those carbohydrates are used in the conversion process to heal that graft union that you've spent a lot of time and energy on. Temperature requirements now for Carolina Strongback in order to get that. You basically can go with growing that at 70 or 75. You'll notice that the same 18 to 21 is basically the ideal light requirements. And if you notice what happens, if you go up 5 degrees Fahrenheit or basically 3 degrees Celsius, what happens to that? Now, if you're growing interspecific hybrid rootstock, you want that one is harder to control. And so over the years, we've said that we'll accept 50 millimeters in length because we have a hard time controlling that. This just gives you an example of what that is it looks like. Notice the size of the cotyledon leaves because the interspecific hybrid rootstock produces an enormous size cotyledon leaf. But you'll notice that this length is 50 millimeters. Now, if you look at the temperature requirements for that, you can see that you don't have to have the light intensity. You can get down to, in some cases, 15 to 18, 15, basically 15 to sometimes 12 hours of daylight to achieve the length that you want, which is the red line here. So that's important also to keep in mind as you may be using the interspecific hybrid rootstock. Now let's look at the planting scheme that's involved. With Carolina Strongback, since it is a wild watermelon rootstock, we like to plant that first. And then 3 to 4 days later, we seed our scion material. Remember to follow the recommendations on seedless watermelon seeding. Over the years, Dr. Schultheis at NC State and myself at Clemson University developed a PowerPoint presentation that shows you the best way to get best uniform germination of seedless watermelon. But if you are still using the interspecific hybrid rootstock, you wait to put that into the ground until the scion material plants have fully emerged from the ground. And that way, you have both the scion and the rootstock at the ideal stage when they're ready to be grafted. So you'll notice the difference here between Carolina Strongback and the interspecific hybrid rootstock. Big, big difference in how to plant that and handle that. We recommend that you use the one cotyledon method. This method can also be used with machinery, with grafting robots that we've seen, both semi-automatic and fully automatic robotic operations. This just shows you the process that's involved in that. And I want to take you now to some points that we've learned over the years in our grafting operations. This shows you the Carolina Strongback as we remove all the meristematic tissue from both these areas. If you fully remove that tissue, it's very important that you do that because you do not want the plant to try to revert back to what it was before, and that will do that through meristematic tissue. Over the years, we've developed a process of blinding that rootstock material to keep the meristematic tissue from ever regrowing. Also, Carol Miles at University of Washington has also developed a method of blinding the rootstock material to keep that from regrowing. But it's very important that you remove all meristematic tissue. So catching this at the ideal time. Now, with the interspecific hybrid rootstock, if you should see this area when you're grafting with a hollow stem, this is detrimental to your grafting procedure. this occurs, your grafting union will not work. Or if it does, the grafting union is very, very weak. Okay. This happens in the interspecific hybrid by leaving it just one more day. Whereas the Carolina rootstock does not develop this hollow stem. Makes it much easier to graft. But if you use the interspecific hybrid rootstock, watch out for that in your grafting operation. I just want to show you now a video that gives you an idea of how our grafting operation is done. Remember that with your razor blade, do not put pressure on it. Let it glide through your 30-degree angle. See how that just slid through? It's very important that you do not damage this area here by forcing that razor blade through. Razor blades are cheap, and so when they become dull, you will damage this unit here, this area here, which you want to make sure it's perfect shape to adhere to the grafting operation that you're asking that now to perform. So do not damage that. This just gives you another of that 30-degree angle that you're shooting for. And this is very important. If you'll notice that my third finger is underneath the cotyledon leaf, your rootstock material, and you're holding that grafting union, grafting of the scion material between your thumb and first finger. You can put that right into place, hold it right into place. It does not wobble. It holds it right firm, right into the place where you want it. Then you simply push that clamp on when you're done. Notice you want to have your cotyledon leaf pointed more in the upward direction. That keeps water from pooling right in this area here and causing your grafting union to rot. Next, you want to put that in a controlled environment of a healing chamber. This healing chamber, the humidity controls inside that healing chamber are very, very crucial to your grafting operation. However, if you notice the lighting in this is not all that intense. It's also grow lights that you can find in everyday buying in the hardware store. You notice that the light intensity in this healing chamber is set at only 35 micromoles. The operations that I've seen through the years, people have spent a lot of money on making sure that you have a high light intensity within the healing chamber. We found over the years that that is not necessary, that you can get by with just enough light that you can visually check your grafting unions as they're in the healing chamber for that entire week. Temperature, 75 to 80. We found more that the 75 is more of the ideal temperature. But the relative humidity, at least 95 to 98% relative humidity for that week that it's in the healing chamber. This will produce quality grafting unions. This is your Carolina rootstock grafted onto a scion material that's a seedless watermelon. And notice what was in that chamber. You developed another fully developed leaf. The same thing was done with our interspecific hybrid rootstock. The same rootstock, when it has developed an additional leaf, but it's a little bit farther behind what you saw with the Carolina Strongback. Notice this root system. Carolina Strongback, once it gets established, is a very, very aggressive root system. When it gets out into the field, it wants to grow, and it will transport that energy into your scion material, and that you will produce quality plants, a lot of foliage, which will protect your fruit and also has the ability to produce more uniform quality fruit out into the field. I hope this video has been of assistance to you. If you have any questions, you can feel free to contact me. Over the years, we've had a lot of fun developing this rootstock, and I hope you find it as much of a rootstock that we've seen that has really benefited a lot of growers that have used this. Thanks again for your time, and I hope you enjoyed this presentation. Thanks again for your time.